Welcome my dear students, new session. In the previous class we discussed about the linear equation and discussed about the how to represent it geometrically for a unique solution, geometry for a no solution, geometrically with a infinitely many solutions. In a unique solution we say that if a equation intersect in a single point, then we can say that two or more equations intersect in a single point, we can say the system has a unique solution. If we have a two or three lines are the parallel, then we can say that system has a no solution. And if we have all the lines intersecting the same coincide with the same, this entire line is the solution of this system of equation, we can say that the system has a infinitely many solutions. And also we show that the linear equation are the equation which is where the all the powers of x is equal to 1 and a1, a2, an are the any constants and b is also the constant. In this class we have to discuss about the system of linear equations, means we have a equations linear equation in the more than one form of this, then we have to call this is the system of linear equation. We have to so this means if a finite collection of a linear equations, you know that the linear equation means we can say that a1 x 1 plus a2 x2 plus so on plus an xn is equal to b, where x1 x2 xn are the variables, this is called is the variables, and a1 a2 an are the coefficients of this x1, or these are the real number, and b is also is some constant. So means we can say that a finite collection of a linear equation in variables x1 x2 x3 is called the system of a linear equation. Finite linear collection linear equations means finite collection of a linear equation means we have maybe two equations, we have a three equation, four equation and m equation, and we have a number of variables remain in the same of all this equation. So this means suppose one of the example, this is equal to this is the clearly this is a linear equation, and this is another linear equations we have and this is another linear equation we have So this is three linear equations we have giving is there, means collection of a finite linear, this is a linear equation, this is a linear equation, this is a linear equation, is a linear equation of the system of equation, because is a variable, this can be written as z times 3 times of 0 times z in the second equation also. So this means the variable involving in these equations, three equations is x, y, z, means three variables involving, and then we have a three system of three equations are there collection. So this is the one of the examples of a system of a linear equations. And now solution of a system, because you know that what is the solution of this we for a linear equation, we know that x1 a1 x1 a2 x2 plus so on, we have an xn is equal to b, then we can show that s1 s2 up to Sn is the solution of this system of linear equation. Then we can say that a1 s1 plus a2 s2 plus so on an Sn is also b, means is satisfy the equation. Then but here because we have a system is a collection of a linear finite number of linear equation, that means we can say that a solution of the system of linear equation in n variables is an n tuples of the number that satisfy each equation in the system. Means if we can say that if we write this is equal to a1 x1 a2 x2 and so on plus an xn is equal to b, we have to write b1 x1 plus b2 x2 plus so on, we have a bn xn is equal to b2, and suppose b3 x1 plus b2 x3 plus so on, we have a bn xn is equal to b3. In the similar fashion we can getting this equation for a moment, this is three equations are there, and now we can say that if this three equation is equal to s1 s2 up to sn is a set of a solution, is the solution only if we satisfy a1 s1 plus so on an sn is equal to giving the b1, and now we have a, we can say that is a b1 s1 this is not, this is leave 2 now this is this is b1 b2 and so on up to this is equal to, we have a bn sn is equal to, we have a this is I take some different is equal to c, so this is equal to, you have a c is satisfy this set of solutions satisfy both the equations, then we can say that this is the solution of this linear equation, otherwise not. For example, I take this one of the example of this. This is the system of linear equations. Now can see if we can say that this is the solution of this equation, system linear equation. This is a 4 linear equation, 4 variable involving. That means this should be satisfy all these equation. This means this, if we take a 1 plus you have a 2 times of a minus 2 plus 3 times of a minus 1, then plus you have a 2, then this should be satisfy all the equation of a this. If it is satisfy this equation, then we can say that clearly is a solution, otherwise this is not a solution of this system of equation. So this means clearly we can say that is equal to, you have a minus this is I think this is not a possible solution. Why? Because you take a minus 1 and then you have a 2 into minus 2, this is equal to 1 plus minus 1 minus 4 and minus 3 plus 2. So this is equal to 3 is equal to minus 4. So this should be equal to either minus 4, and if we had taken from this is equal to minus 5 and minus 4, and then you have a minus 1, and then you have a plus you have a 2, then you have a 5 for 9 and 10, then you have a minus 10 plus 2 is equal to minus 8. This satisfies this equation. Now then set the third one, we can just say that is equal to 3, and you have a minus 4 to the 8 and minus 7, and then you have a plus 4, then you have a 4 to the 7, then again it satisfies this equation. Now here we can just say that 1 minus 6 minus 5 and plus 8, 8 plus 9, 8 plus 8 plus 1 9, and 5 and 6 11, then is equal to 2. So this should be is equal to either this should be not a then here you can just see this clearly. We can say that this should be 1, and then you have a minus 4 and minus 3, and then you have a plus 1. So this is equal to, plus 2, and then equal to plus 2. This is equal to, you have a 4 1 minus 3 minus 7. So 3 minus 7 is equal to minus 4. Either we have to take is right hand side is equal to minus 4, or we take here somewhere we take a as if you want to a 0, then you can just say that this x1 or somewhere you can change the equation is there. So this means sorry, this is not a 0, this should be a minus 4. That means this is the satisfy each and this all the equations of this system. This means we can say that this is the solution of this system equation, which here is not 0, is a minus 4. Okay, so this means we can say that general form of a system of a linear equation. We have a m system, m linear equations, and n unknowns variables x1, x2, xn. So we have to write in the form of a11, ax1, a12, x2, and so on. This is b1, b2. We have a, because the system equation is equal to m, so we have a, this is a total m equations are there, and then we have a variables are, you have a n variables are there. So this means we have a, this is equal to n numbers unknowns are there. So we have to find the value for x1, x2, xn. For this, where all a, I, j and b, i's are the belongs to the R, and a, I, j, I ride between 1 to m, j riding 1 to m. So this means we can say that simply is equal to this is I running 1 to m, j running 1 to n, because number of variables is equal to you have a n, and number of equation is you have a m. Okay, so now a solution of a linear system is an ordered tuples S1, S2, Sn, such that each equation of the system is satisfied by substituting Si in place of a Xi. This means if we have to substitute Si into the all of them of a system equation which satisfies giving to the solution, then we can say that this is the solution of this thing. Now, if we have to solution, then we know that how can say that this satisfies the is a solution or not. If the system has a solution, then we can say that it is a consist. If the system has no solution, then we can say that system has a inconsist. It's a linear equation is called a consist if it has at least one solution. It means at least one solution means if the system has a solution, one unique solution, or system has a infinitely many solution, then we can say that system is a consist. If system has a linear system is called inconsist if it has a no solution. Simply we can say that it is called as inconsist if it has a no solution. That means we can say that clearly if you have a system of equations, then if system of equation has only at least one solution, we can say that at least one solution, maybe the system has a unique solution or infinitely many solutions. There are three types of solution. We say that either is a unique solution, you have an infinite many solution, or you have a no solution. So this means we can say that there is a three possibilities are there. If we have a unique solution or infinitely many solution, then we can say that system is a consist. And if system has a no solution, then we can say that system is a inconsist. And in this equation, this way, if we have to just take this, all the b's are this term is this is equal to 0, this is equal to 0, all of them is 0. Means all bi's are 0. This means we can say that all bi's is equal to 0. I lies between this lies between 1 to m. Then we can say that the system is called as a homogeneous system equation. Means right hand sides of this is equal to 0. When all bi's are 0, then the system of linear equation is called as a homogeneous linear system of equation. Means all the right hand, not at least one, means all the bi's are equal to 0. Then we can say that the system of equation is a this system of equation is called as a homogeneous linear equation of a system, or a system of a homogeneous linear equation, or homogeneous system is there. Okay, so now we just clearly we have to say the solution. If the solution exists, we say that the system is consist. If the solution is not exist, then we can say the system is inconsist. If all the right hand side is equal to 0, then we can say the system of linear equation is called as a homogeneous system of linear equation, yeah, homogeneous system of equation. Okay, now the natural question is this: is every homogeneous linear equation consist? That is a very interesting question is there, because you say that we can say that homogeneous linear equation means what we have this. For example, I take a 2x plus 3y plus z is equal to 0. We take a 5x minus y plus 3z is equal to 0. We have a 3x plus 2y and leave this. This is equal to 0. We have this is the system equation. This is clearly is a homogeneous system of equation. If this is a clearly homogeneous system of equation, then the question is that every homogeneous system equation is a consist or not. For a consistence, we know that by the definition of a consistence, we can say that the system of linear equation is a consist if at least one solution is exists. Means either unique solution exists, as infinite many solution comes, at least one solution is exists. Then we can say that the system of equation is a consist. So this is means we can say that if you take clearly, if you take a 0 0 0 is the clearly one of the solution of this system, because this 0 0 satisfy all these equations are there. We have x is equal to 0, y is equal to z is equal to the sum of all this is equal to 0. So this means we can say that the naturally the question answer of this question we can say that yes, every homogeneous linear system consists and at least one solution is exist. At least one solution is exist. Yes. Because all the system have the 0 0 vector as a solution. Why? We can just clearly I explain you. Means we can say that by the consistent at least one solution exists. Yes, 0 vector we have always the solution of every homogeneous system of linear equation. So if this 0 0 vector is always a solution of a homogeneous linear system of equation, then there is maybe other possibilities also, and this solution is called as a trivial solution. Clearly this solution is called as a trivial solution. Maybe there is some non-trivial means except 0 0 if any other solution is exists. One solution is clearly exists is the 0 0 vector, but other than the 1 0 0 is also there is some solution is exists, then we can say that the system has a non-trivial solution. If there are other solutions besides the trivial one, they are called as a non-trivial solution. So this means we can say that if we have a system of linear equation, homogeneous linear system of equation, as every homogeneous system equation is consist and has a one solution, whatever one solution is exists, the 0 0 vector is always is a solution, and this solution is called as a trivial solution other than this trivial solution, if any other solution is also exists for this system of equation, then we can say that this system has a non-trivial solution. For example, I take this example. Now, can check this is clearly is a homogeneous system of equation. And now, if homogeneous system of equation, we can say that clearly you can say that x is equal to 0 and y is equal to 0 is a solution of this equation. Now, if we take a 3 is common from this anything, this we can say that this equation x plus 2y is equal to 0, then x plus 2y is equal to 0. That means these two equation is coincide. If you take these two equation is a coincide, and that means this is an infinitely many solution, then you can say that clearly x is equal to you have a minus 2y. If y is equal to we take a t is any real number, then x is equal to you have a minus 2t, then you have to say that minus 2t and t such that t is any real number. This is the solution of this linear equation, homogeneous system of a linear equation, and that is an infinitely many solution of this trivial this homogeneous system of equation, and that means we can say that this system has a non-trivial solution. So why? Because the trivial solution is already there. This is the trivial solution. We have to say that 0 0 is the trivial solution, and another solution of this equation is depend upon to the minus 2t and t, where t is any real number. If we take a t is equal to 1, then you have a minus 2 comma 1 is the solution. If we take a t is equal to half for the moment, you have a minus 1 by 2 is the solution. If we take t is equal to you have a 2, so minus 4 comma 2 is the solution. So this means all this solution is there. You can verify this. If for example this we take minus 1 and half is the solution or not, we can say that minus 1 plus 2 into half is equal to you have a 0. Then you have a minus 3 plus 6 into half is again 0. That means we satisfy this equation. So this means we can say that clearly 0 0 is a trivial solution. The second equation is a multiple of the first. There are infinitely many solutions. So non-trivial solution exists. Hence the homogeneous system. This homogeneous system is consist and has more than also is a infinitely many solution. One is that solution is exist trivial solution, and another solution is exist as a non-trivial solution is infinitely many solution. Okay, so now we can say that another system is if we say that equivalent system of linear equations. Suppose we have a given is the two system of linear equations in n variables, and we can say that these two systems are said to be equivalent if both the equation has the same solution set. We can say that if we have a one linear system equation, another linear system equation, if both the system has the same solution, so n tuples means satisfy the first system, also satisfy the second system, means we have a two system of equation, we have a and b, there the two system of equations are there. If n tuples means satisfy this equation and also satisfy this equation, or n tuples satisfy this equation, then also must be satisfied with the first equation, then we can say that these two systems are said to be equivalent. So every n tuple satisfies the second system, also satisfies the first system. Means clearly we have a for the solution point of view, we can say that if we have any set of a solution of a equations, we can say that this is called the system is called as a equivalent system. If we have a one set of a solution, this satisfies the one set of a system, the solution, this same solution is satisfy the second set of solution, then we can say that these two systems are equivalent. Also, in other words, two systems are equivalent if they have exactly the same set of solution. What I am explaining you means we can say that this is the line. We can say simple word, we can say that two system equations of n variables are said to be equivalent if two systems are equivalent if they have exactly the same set of a solution. If we take, for example, I take this system of equation, and then I also take these two. These are the two different system of equations now we take. Now, if you find the solution of these two system of equations, then you can check whatever this. For example, this we take by this we try to eliminate by this. So we have a 2x plus 5y is multiplied by 2 minus 2. So minus 2x and minus 2y is equal to minus 2. Then this is cancel out. You have a 3y is equal to you have a this is equal to 2 minus 1 is equal to minus 1. So, y is equal to minus 1 by 3, and if y is equal to minus 1 by 3, you have a x is equal to, you have a 1 plus 1 by 3. So, you have a 3 for 4 by 3. So, x is equal to, you have a 4 by 3. Now, you check, you have a 4 by 3, and then you have a minus 1 by 3, then you have a clearly is equal to 1, and you have again the satisfy this equation, x is equal to, you have a 4 by 3. So, you have a this is a 8 by 3 and minus 5 by 3, then you have a sorry y is equal to, you have a minus 1. So, minus 5 by 3. So, we can just check this 2x, I think somewhere I have to mistake somewhere, 4 to the 8 by 3 minus 5 by 3, and then you have a 8 minus 5 is equal to 3 by 3 is equal to 1. So, this is somewhere in mistake, I think. So, this is, I take somewhere, this is maybe this is equal to 1, not 11, this is 1. Yes, this is a 1, not 11, I think so. Okay, so this is equal to or maybe this take differently, minus 2 and 3. We just check, verify this x is equal to, so this we just take just again 2x plus 5y, oh sorry 11, I take sorry, I make a mistake, 2x minus 2y is equal to minus 2, then this is cancel out, then you have a 3y is equal to 11 minus 2, not 1, I just previously I write a 1 here. This I mistake, this is not minus 1, this is equal to, you have a this all is not correct. Now, we have to just say this is correct. So, this is 9, then y is equal to, you have a 3 is a 9, and y is equal to, you have a 3, then x is equal to, you have a 1 minus 3 is equal to minus 2. So, this means clearly you have a minus 2 and 3 is the solution of this satisfies both the equation. You take a minus 2 plus 3 is equal to 1, then you have a minus 4 plus 15 is equal to 11, and then also just check into this. So, this is first one is clearly satisfied by here, then you have a x is equal to minus plus 4, and then minus 3 to the 6, that is equal to minus 2. This is satisfied. So, this means we can say that this is our minus 2 comma 3 is satisfy both the equation system of equations. So, both the system represent the same line, and then both therefore have a same solution set 2 minus 3, and they are the equivalent system. So, this means clearly this two system has a same solution set minus 2 and 3. So, this means we can say that this clearly these two equations has a consider and has a equivalent system. Okay, so that means we just say that we can say that this now geometrically we can represent this system of equation, because this say that both the system represent the same line. If we have to go to the geometrically into this this way, we can go to the geometrically explain you, because we have a one line is x plus y is equal to 1. So, this is the line we have just said that x plus y is equal to 1, and now we have a, if y is equal to 0, then y is equal to 0, then x is equal to, you have 11 by 2. So, this means x is equal to, you have a 11 by 2. 11 by 2 means you have a 2 somewhere and here somewhere you can just say that this is x plus y is equal to 1, and then you have to can say that this is equal to, you have a x plus y is equal to 1, and then we have a the point of intersection somewhere, I just don't know, this is equal to x 11 by 2, x is equal to 11 by 2 means you have a 5 point somewhere 5.2, this is 11 by 2, and then we have to just say that in the second equation we have a y is a, if x is equal to 0, then we have a 11 by 5, then you have a somewhere equal to 2 point something. So, if we take a line this is going to this is intersecting somewhere point, and this is nothing but is equal to, we have a line this is the point we have is equal to minus 2, and this is the point we have x is equal to, you have a 3, and now this is the point where this is the, you have a point minus 2 comma 3, and this is the, clearly we can say that this is the set of a line satisfy this condition of this point of intersection. So this means this system has a clearly 2 and minus 3 is the solution by the geometrically. Also we can say that means this system, both the system represent the same line, and if you take, this is the line we have this is the line, we can say that 2x plus 5y is equal to 11, and if we take this second line, you can say that you have a, if x is equal to y is equal to 0, then you have x is equal to 1. This is representing the this time. So this is the same line, we can represent it as a minus 2x minus 2y is equal to minus 2. So this same line representing as here, because we can take a x is equal to y is equal to 0, then x is equal to 1, then x is equal to 0, then y is equal to 1. So we can say that 1 1. So this means this represents the same line again. So this minus 2x minus 2y minus 2, and this x plus y is equal to 1. So represent the same line. This means both the system represent the same line. This is the common line of both the system of equations. So that means we can say that and also we can geometrically say that this system is intersection at this point minus 2 comma 3. So we can clearly say that this are the two system has a we call these two system are equivalent. So this means we can say that the systems are equivalent only when we have a set of a solution, and this is a set of a solution is satisfy both the equation or all three equations are equivalent. We can say that if the solution of this set of equation is satisfy all the system of linear equations, then means we can then find the system of it. Okay, now just move to the next step is in this how to solve the system of linear equation. There are various methods for solving the system of a linear equation, and one of the method of we can say that a Gauss elimination method, and also is called the elimination method, or called the Gauss elimination method. That method is I just explain you a little bit about this this here, and then we have to in the next class discuss about details about this Gauss elimination method. The method is depend upon we have a system of equations. We have to try to solve the these system of equations by the elimination. This is by the name is itself it is eliminating Gauss elimination method, means we have to eliminating the variables. Means we have three variables are there, x, y, z is equal to, we have a three system of equations, and we have to, with the help of a first equation, we remain the first equation as it is, and then with the help of a first equation we have to in the next two equation remove the x variables from these two equations. And in the next step we go to the first remain equation the same, second equation remain the same, and then in the third equation we remove the y terms into this, and then we get a one form of a this equation in the form of a like the triangular form, means we have to getting this x1 plus x2 yeah, just I write like this, x y plus z is equal to some b1, and then next step should be we have a y plus z is equal to b2, and then z is equal to you have a b3, and this form is this also called is a triangular form of a system of equation. We convert into the triangular form, and when we convert a system of equation into the triangular form, then you can see easily, you see if we have a right in triangle form, we get the value for z, substitute z value into the above equation, we get the value for y, substitute the z and y into the above equation, we get the value for x. So that means after reducing the system of equation into the form of a triangular form, or we can say that elimination by the eliminating method, and we obtain the value for x, y, z, and then after the triangular form we have to go to the back substitution, substitute z value in the above equation, we get the y, substitute the z and y value for the first equation, we get the value for x. So in this way we can just calculate, this way we can find the solution of this. Such a solution is called is a Gauss elimination method. So, in this next class we try to explain you about what about the Gauss elimination method and try to discuss some examples related to the Gauss elimination method, and then we have to move to the relate the linear equations, system of linear equation to the matrix form, and if we have to write the equation into the matrix form and how to same operation can be applied in the matrix and we get the solution of this equation. In place of solve the system equation, we solve the matrices, and then by the matrices we getting the solution. So, I have stopped today's class here and we discuss all this thing into the next class. Thank you very much.